And here's the idea, and that's what we're going to flesh out today. Okay, we need a way to measure not just the size of the hypothesis set, but also its diversity. So let's play along with an experiment. Okay, fix any number of data points you want, let's say n. Now, in theory, if you have a hypothesis set with 50 hypotheses, then it should be able to, implement 50 different ways to classify that data set of size n. Okay? And if it's not a very diverse hypothesis set, it won't be able to implement all 50 ways to classify that data set. Okay? So the real insight here is not to specifically count how many hypotheses you have, but to count the number of ways the hypothesis can classify your data set, okay, for some fixed data set. Okay. And I'm going to illustrate that in a sort of a cartoon experiment here that we're going to play, and I can do this, with my slides, and so, bear in mind that, this may not represent reality totally, but imagine a hypothesis set that looks something like this. So this is sort of, a collection of perceptrons, okay, where I'm imagining that all these perceptrons are all different lines, and, the top right is +1 and the bottom left is -1. Okay. Now, looks like a very complicated hypothesis set, lots of different perceptrons, and if we counted, it's probably about 20, who knows. But now what this idea that we are sort of nurturing here is that, let's not measure the complexity of the hypothesis set by the number of hypotheses. Let's consider what it can do on a data set. So let's generate a data set. Okay, so on the right, I've now generated a data set of data points. Okay, nice. So this is a data set of, approximately 9 data points. Okay, and we've got all these hypotheses. And now we can ask, okay, now, if I pick one of the hypotheses, it's going to classify the data in one particular way. If I pick another hypothesis, it's going to classify the data in another particular way, and so on and so forth. But wait a minute. All the hypotheses in this hypothesis set are going to classify that data set in exactly the same way. No matter what hypothesis I pick from this collection of hypotheses, all the top right data points are going to be blue, and all the bottom left data points are going to be red. Okay, so now here is the punchline. Viewed through the lens of this particular data set. Okay. Viewed through the lens of this particular data set, that hypothesis set on the left, which has all these hypotheses, is effectively just one hypothesis. Okay, so I'm going to let that sink in. All those hypotheses there, with respect to what they can do on this data set, basically collapses to just one hypothesis. Now, isn't that interesting? So, while I might have, in fact, there are infinitely many hypotheses that I could have, shown on the left, and then they would all collapse to one hypothesis on this data set. Okay. And we are going to now develop a measure of complexity for a hypothesis set that can take that into account. Okay. And you can think of it as an effective number of hypotheses. Okay. So, the size of H only captures the maximum possible diversity, and it's overkill. Okay. But we're going to now look for a way to also capture the diversity in the hypothesis set. Okay. And if a hypothesis set is very diverse, it should be able to implement many different ways to classify any particular data set. And we call the ways in which you can classify a data set the dichotomies. Okay, and if you cannot classify a data set in many ways, then it's not a very sophisticated, it's not a very diverse hypothesis set. Okay. And we're going to introduce this concept of the growth function, which is going to quantify exactly this. And that is going to end up being a better measure of complexity for a hypothesis set. And it turns out that that measure of complexity is going to be useful in deriving this generalization bound that links E out to E in for infinite hypothesis sets. Okay, now, we're going to move to the board because A, this is an important topic. I need to go slow, and the board is always better for math-related stuff.